see it if you need to later. So we're going to do 4 or 5 today, which is about factoring in general, and we're going to factor polynomials, okay? We're going to use greatest common factor, and we're going to look at what are called special products and a method called grouping. And then in the next section, we're going to factor quadratics specifically using different methodologies I'll show you. But again, the reason we skip 4-4, here's what 4-4 is all about. 4-4 is about being able to identify greatest common factors and least common multiples, and then being able to factor something to its prime factorization. So you learn about these when you're, this is literally stuff you learn in the beginning of middle school. Least common multiples. So for example, if I had a number like 5 and 4, what's the least common multiple of those two numbers? What is it? 20. Because 5 and 4 both go into 20. Is there any number below 20 that they both go into evenly? No. Factors of multiples of 5 are 5, 10, 15, 20. 4, 4, 6, 12, 16, 20. 20 is the first thing they have in common. That's the least common multiple of 5 and 4. The second part of 4-4, so I can literally go through 4-4 in 3-4 minutes here. GCF, greatest common factor. So let's try 24 and 16. What's the GCF of 24 and 16? 8. How come it's 8?
No greater number equals 1 and 2 both of them.
Correct. No greater number can go into both of those evenly. Sure, there are other answers. What's another common factor of 24 and 16? Give me another common factor. 4. What else? 2. Is that it? 1. Yeah, good. I know, it's a good point. 1 is a common factor of all numbers. So what are common factors? If we're confused about this, we break up 24 into its factors. 1, 2, 3, 4, 6, 8, 12, 24. All of those numbers go into 24. They are all factors of 24. And then the last thing is called prime factorization. Prime factorization. So what's the prime factorization of 48? And you can go one step at a time. You don't need to give me the answer right away. How would I find the prime factorization of 48? There's no wrong answer to start, by the way. You could start this with any set of factors. There's no wrong answer to start here.
I'm not sure off the top of my head, but I'm pretty sure the answer comes off like 2 times, right?
Yeah, but give me some factors. I'm saying start off. Give me some factors of 48. Doesn't matter what you tell me. Dude, let's start with that. Okay, can I break up either of those further? Sure. So I continue to go. So did it matter where I started? No. If you did 8 times 6, then you break up 6, you break up 8. If you did 16 times 3, you break up 16 then, right? You follow what I'm saying here? So prime factorization simply means keep breaking it up.
Until you hit
Is that correct? Yep. 2 times 2 times 2 times 2 is 16, times 3 is 48. Okay? The prime factorization of any number. If you started with 8 times 6, it would have been quicker, right? 8 times 6, break up 8. 8 is 2 times 2 times 2. 6 is 2 times 3. You still end up with 2 times 2 times 2 times 2 times 3. So the prime factorization of 48 is 2 to the 4th times 3. Is that clear what I'm saying here? 2 times 2 times 2 times 2 times 3. That's our answer. Remember, prime factorization, it's self-explanatory. The factors need to be prime. The factors need to be prime. All right? All right, cool. That was everything in 4-4. That's why I skipped 4-4. So let's 4-5. Let's start with this concept. We already talked about this a moment ago. The greatest common factor. It's a factor that goes into all of the terms. But with a polynomial, we have to be a little bit more careful. So let's start by looking at a first example of the polynomial. What's the greatest common factor of the following expression? You only have 2 terms, so really you only need to find the prime factorization of these 2 terms. And that's the easy way to start it. But you don't always have to find prime factorization of these. Okay, but if you want to, you can. What's the prime factorization of 6x cubed? What's the prime factorization of 6x cubed? What does 6 factor into? 2 times? Thank you. X cubed is just x cubed. Remember, something that can be raised to a power does not have to be broken into like x times x times x. You can write it as x cubed. It's still considered prime factorization. 15? 15? 3 times 5. And then that's times x squared. Now, I might want to do this on the next line. Because now it just looks easier when I do this. So for those that have trouble with factoring or greatest common factor, this is a good approach to use. Why did I break up x cubed into x squared times x? Bridge?
On the other side of the equation, or the 5 times 3, that part, that's only an x squared. So this would kind of be the greatest common x squared value that you can get, or x value that you can have.
Exactly right, Bridge. Very good. What else is common amongst both, Bridge?
The 3.
The
So
3.
The greatest common factor would be 3x squared.
So that's what comes out in front. A lot of you can do this by looking, right? You all see what I'm saying? And that's fine. But if you want the steps along the way, you can use them. But if you look at this original, I can look at the original and see, 3 goes into 6 and 15, that comes out. X squared is in both of those terms in the original, that comes out. How do I know what's left over now? How do I know what's left over? What's left behind, Ruth?
Anything that's not
Underlined.
yeah.
So what do you got?
2 and 5 and x.
Let's put it in that order, right? So 2x minus 5. Again, look, whatever we didn't underline as a common factor is left behind. It's been, the other parts, the 3x squared, has been removed out front. How do you know this answer is right? How do you know this answer is correct? Do you have a question or an answer?
Oh, no, answering.
Yeah.
So it's like when you multiply that, you get the original equation.
Very good. Very good. If you multiply this answer out and distribute 3x squared to both, wouldn't you get back to the original? You absolutely would. That's how you know it's correct. Now, does anybody really want to do this every time? Honestly. Probably not, right? You probably don't want to do this every time. So instead, once you bring the 3x squared out in front, to see what's left behind, if you didn't have this, make believe we didn't write this, okay? So this is no longer here. How would you figure out what's left behind now? It's easy when you see it here, isn't it? Look, 2x, 5, boom, we're done. How do I know what's left behind if I didn't have this piece of information in the middle?
I just did it mentally and just took 6 times. I just made 6 times. 3 goes into 6 2 times, so I did 2x, and then it goes into.
What's left behind?
And then the x is left behind.
So what operation are you performing? Come on. Yeah, good. With confidence. He's right, but he needs to explain it there. With division. So take this quantity in your mind, divide it by whatever you take out. 6 divided by 3 yields 2. X cubed divided by x squared yields x. And that's what's left behind down here. Is that clear what I'm saying? Write yourself a note if you're not sure about this. The signs always carry, so the minus sign carries in front. And then if I take 15x squared and divide it by 3x squared, what am I left with simply? 5. And that's what we got down here. So again, when in doubt, after factoring out, divide through. You're not really dividing though. Do you see what I'm saying? I can't tell you how many students try to say, I'm just dividing both sides of the equation. Do you see an equation here? No, this is an expression. So you're taking this original statement and dividing it in your mind by whatever you take out in front, and then write what's left over after you've done that division. Any questions? Yes, George.
What's the point of doing all this stuff?
So there's a huge point. Great question, George. So right now, all you're doing is practicing a technique, right? That's all you're doing is you're learning a technique. But later, when you start to, nice catch, when you start to do more stuff with calculus and more advanced math, there is a ton of factoring involved so that you can come up with a general solution to an applicable problem. So when you're trying to do things like optimization, the calculus involved there, a ton of stuff has to be factored actually. So you're learning a technique to later use with applications. You're not probably going to use too much of it applications right now, But in sections 4.8 and 4.9, we do some problem solving with this. So when we get to that, you're going to see where the factoring does come in. Okay? But then it's all applying it to science or some sort of applied math later. So let's look at example 2. And let's recall that we have a rule. So we looked at greatest common factor. That was example 1. So we're kind of done with greatest common factor for now. We'll see it again, but we're done with it for now. Let's look at this rule and remind ourselves of this rule. The rule we learned in the last section was that when we multiply binomial conjugates, remember, these are called binomial conjugates. When we multiply binomial conjugates, we always end up with a difference of 2 squares here. That's the rule that was presented. So can you take that and move backwards now? I want you to take this idea and go from here and move backwards to the factored form. So take the difference of 2 squares that's presented to you in A, B, and C and move backwards to the factored form by applying the reverse of the rule that you see above.
So for A, it would be like u minus 7, u plus 7.
Okay.
Okay.
I'm assuming you're going to get through these pretty quickly, so we'll go through these right away. Part A.
U minus 7 times U plus 7.
All right. U minus 7 times u plus 7. So I'm going to go through the example real quick of how to figure this out one time and then assume that we can do the others, okay, from this alone. So the easiest way to approach a problem like this, when in doubt, is to rewrite this in the form of 2 squares. Well, u squared is already a square. That's easy. But what's 49 really? What is that as a square? 7 squared. Once you write it that way, you've got A, you've got B. Just literally plug them in to this equation, or this, not equation, to this representation here. Again, A would be U, and B would be 7. So this is A, and this is B. Again, this is A right here, this is B right here. We got a minus, we got a plus from the minus and the plus. How about part B? Part B does not work right away, unfortunately. Oh my gosh, I can't do it. But what did you just learn about in the previous example? Hannah? So maybe start that one off with the greatest common factor. When in doubt, when you're trying to factor at all, you always start with the GCF. Every single problem you do from this point on, whenever you factor anything, you need to start with the greatest common factor. Ash, what do you got? Greatest common factor? 5x. Let me the overall thing. What do you got? X squared?
X squared minus 4.
Now, we can see clearly here that we have a GCF. It's also kind of clear, but maybe not necessarily, that we have another thing that can be factored further. This is x squared minus 2 squared, really. A is x, and b is 2. Is that clear? This is really x squared minus 2 squared. So a is x, and b is 2. So Ash is exactly right. X plus 2, x minus 2. Does it matter that I wrote a plus and then a minus here? I wrote a minus and a plus. Does it matter? Why not? Why doesn't it matter which order I write my binomials in? Max? It is commutative. Very good. And finally, part C. Part C looks like it's confusing at first, but it's not that bad. It's really not. George, help me out.
So, I didn't get up to this, but I don't know.
Well, what's 36 as a perfect square, George?
6 and then
Okay, what's 25, George?
5.
Okay, and what goes in there for the r that when I square it gives me r to the 6th?
R to the 6th. Because, or wait, no. R to the 4th.
4 times, remember when you raise a power to a power, you multiply powers.
Oh, so it's 3.
There you go. So, do you see what I'm saying there, George? So again, in your mind, you need to be asking yourself this right here. Please, if you didn't get this right away, please, I hope you're looking. You need to be asking yourself, what thing squared gives me this? And what thing squared gives me this? Well, the answer is 6 gives you 36, and 5r cubed squared gives you 25r to the 6th. Okay, because remember, r cubed squared is 3 times 2, giving you 6. A power to a power, those powers are multiplied by each other. So A is thus 5r cubed, and B is 6.
For those problems, if they're like whole number,
There are whole numbers that could be divided by 2?
R cubed.
Yeah, it's always divided by 2. Yep, that's what it turns out to. Because if you had r to the 8th, it would be r4, or r to the 4th squared, r to the 8th. So you're really just dividing the exponent by 2. Okay? But it's good to know why you're doing it, obviously. Don't just memorize. Questions? This is one of our special cases, right? So we call this difference of 2 squares. I write dots all the time, D-O-T-S. Difference of 2 squares. You might say 2 perfect squares, but what other kind of squares could you have? A square is perfect, isn't it? So that's a bit of redundancy there by saying 2 perfect squares. But I hear that a lot in books, and other people say it. So let's go to the next one now. This concept here is called factor by grouping. Raise your hand if you've heard of this before by name. You may have seen it by another name, but heard the name factor by grouping. Okay. So factor by grouping indicates that you're going to look at your polynomial and separate it into parts. For those that have done this before, how many terms do you usually have when you use factor by grouping? Any idea?
4.
Usually 4, sometimes more, but usually 4. When you have 3, it's not factor by grouping really, right? When you have 3, it's a trinomial or a quadratic. But when you have 4 terms, it's usually factor by grouping. That's an indicating factor. Maybe jot that down. When there are 4 terms to the polynomial, it's always a good idea to try factor by grouping. And more than 4 also you could use it for as well. But traditionally 4 or more. Let's take a look at the first 2 examples here. So if I look at part A, it looks as if I can't really do much with part A. I can't do too much at all. Because it looks like there's nothing that's a greatest common factor. And it's not like this is a special case. But for those that have done factor by grouping, what do I want to look at? What do I want to try to almost isolate in a sense? In your mind, what are you doing? So a lot of hands go up when you said you've seen this before.
Yeah.
Then suddenly no hands on how to do it. Interesting. Hannah, go ahead.
You can associate the first 2 terms and the second 2 terms because they have a common factor.
Yeah, and she used the words associate, but it's the same word as group. Group and associate are the same thing. So look at these as 2 separate groups. In group 1, George, what's the GCF in group 1?
Group 1 is group 1 is y.
Thank you, George. Okay. What does that leave behind, Bridge, if I take a y out?
It just leaves x plus 3.
Good. Tristan, what's the GCF in the second group?
In the second, you can take 2 out.
What does that leave behind, Tristan?
X plus 3.
Is that a coincidence?
No.
I'm thinking no, right? You know what I'm talking about, the coincidence that might be thought of? What do you see is in both terms now?
X plus 3.
So what could I do with that?
Well, the final answer is
I know what the final answer is. I know a lot of you know what it is. But a lot of you don't know why it is. A lot of teachers teach this rule but don't explain. Why is the answer what it's going to be in a minute. How many terms do I have now? 2. Again, please look up for a second. You started with 4 terms. You grouped the terms. Once you factored this out, this is 1 term. This is the second term. What's common amongst both of these terms? What's common?
X plus 3.
So what can you do when something is common in all terms? What have we been doing this whole time? Oh man, look. What was common in these two terms?
Oh, divide.
What was common in these two terms?
The y.
So what did you do with it? Come on, guys. What's the real word? It's not divide. You're not really doing division.
Oh, sub.
The whole topic is about... What is it about? Thank you, Max. So the y value is in both of these places. So you factor it out, don't you? What's in both of these places? So factor it out. All right, let's take x plus 3 out in front now. If I take x plus 3 out, what's left behind? Y plus 2. So a lot of you know that this is the answer, and I know a lot of you knew that this was the answer. But you need to understand why it's the answer. X plus 3 is now the common factor in both terms. When I take x plus 3 out in front, I leave behind a y here and a 2 here. That's where this other factor comes from in the end. So many students go from step to step but not knowing what they're doing. They see, oh, x plus 3 is in both. That means that that's my factor is going to be x plus 3, y plus 2. Why is that? Because you're factoring x plus 3 out in front right over here, leaving behind a y plus 2. Remember, when you factor something out, look at this, by the way. Did I show you this the other day? Can you put 2 pointers at the same time? Just found this out. So when I take both of these out in front, what am I leaving behind? I'm leaving behind this piece. That's why it's the answer. Please don't just memorize that this is the answer. Understand why it is the answer.
So I noticed that if you look at the original equation, you see the 3, the 2, and the xy.
Mm-hmm.
And it's like indicative of the actual answer. It's possible to just go straight from the equation to the answer.
No, that happens to be... Well, let's look at part B, and then you can answer the question for yourself. How about that, all right? Well, you're going to know what the answer is because of the way I reacted, but yeah, it's not always going to work out that way. It happens to in this case. And it could in others. It could. But it's not always going to. Okay? In part B, I'm going to start by rewriting it so I can see this. Do the same thing, please. Try it on your own. Group these and group these. Check your work, please. Don't look at my answers, but check your work when you're done with yours. There's a common mistake I would love for people to avoid here, so let's hope it happens so we can avoid it. Did everybody get the first part right? Take a look at mine for the first part. I'm hoping we all got that one right? That's the easy one. What's the other GCF? -1. Now, George, I could tell you it's 1. I'm going to say, you know what, George? I don't agree with you. I'm going to take out a 1, and I'm left behind with -5r minus w. I could do that. Why did you say that it's -1, George? Why?
I don't know. Because the other ones were positive.
Yeah, and these have to be what? What do these have to be, George?
The same.
They gotta be the same. Thank you, whoever whispered that one. They gotta be the same. So these have to be positives here. That's the only way this technique works. Please look back up, everybody. Look up here. Look earlier. Remember we were left with x plus 3? And I explained to you how now x plus 3 is common, and therefore x plus 3 can come out in front, leaving behind y plus 2. The same thing occurs here. Whatever you get here, write yourself a note, please. Whatever you get here, you must get here. So if you don't know what to take out of this common factor, just think, how do I get 5r plus w? And as George mentioned, take out a -1. Oops. So now 5r plus w is common amongst both of these. I'm going to underline it so you can see. So I'm going to take 5r plus w out in front, leaving me behind with 2r minus 1. That leaves me behind with a 2r minus 1. Max.
I did it backwards. I grouped
That's
my
fine.
5r and 10r squared.
Oh, say again, actually? Go ahead.
I grouped 10r squared and
Oh, yeah, that's fine. And did you get the same answer? But you probably have them reversed than your final answer. So let me point out what Max is mentioning. Look, he switched the order of these two and did 10r squared minus 5r, moving this over, and then he did plus 2rw minus w. And you can check yourself. And actually, I think in the notes, I think I do it both ways, right? Oh, no, I leave it only one way. But you can do it both ways, for sure. Okay? Doesn't matter. Max's answer is reversed. But again, because multiplication is commutative, that doesn't matter. Makes no difference. How are we doing so far?
No idea.
Oh, it's a C day. Yeah, it's all out of whack. I can tell you one. I'm trying to keep track of the time. 10:22. We got 2 minutes. So I want to go over this last form. It's the last thing of the day. I'll start with this form. It's called sum and difference of cubes. And I want to explain the first example, so if I can get your attention, please. This is very similar to the one with squares. If you could rewrite what you're starting with as cubes instead, all you need to do is apply this formula. And it looks complex. Why does it say plus or minus, minus, plus? Because there's two options. So look at this option here. Is this minus or is this a plus, the first one? It's a minus. What is 8x cubed as a perfect cube? What could I write that as? And what's 27 as a perfect cube? 27 is what cubed? 3, that's easy. What's 8? 8 is 2 cubed, isn't it? And what should go here? X, right? Aren't these both perfect cubes now? If I do 2x cubed, don't I get that? And if I take 3 cubed, don't I get back to here? So what this tells me is the following. You guys are smart. You could finish the rest of this, but let me show you. This is A. This is B. Now, you apply it to this formula. So because I have a minus sign, and it's a minus sign here, I use the minus sign, which is the lower one, and the plus sign. You use the lower signs when you have multiple signs. That's how you denote this. So your answer for this one would be, again, it's going to be A minus B. So 2x minus 3. That's, again, A minus B times the quantity A squared. A is 2x. That's squared. It's going to be a plus from the bottom sign. Then A times B. So it's going to be 2x times 3. And then plus B squared means plus 3 squared. I can simplify that to look nicer as 2x minus 3. This is 4x squared plus 6x plus 9. This will never be factorable if you do it right. Write yourself a little note. This quadratic that you get as a result will never be factorable. This is your final answer. Now, before I leave you with this, because the bell's going to ring, part B is rather simple. Part C. Can you start part C right away? What do you have to do for part C to start? Take out what? Take out a 2u or a GCF. So take out your GCF of 2u first, leaving behind u cubed plus 27. And now you'll have cubes. Okay? You're going to finish this over the weekend, tonight for sure. And then make sure to do the homework. Homework is on the next slide. Okay, you can watch the